Good morning, everyone. Today we're going to look at a question that came in the 2019 Grade 12 Science Paper 1 question in Section B. And this particular question is actually the first question in Section B, and it deals with linear motion. And when it comes to linear motion, we know that a question can come and the way we solve it can involve equations of motion, or it can be a graphical question. In this particular case, the question is a graphical question. So let's get started. The question reads, Figure B 1.1 is a graph showing how velocity of a car changed when the driver applied brakes upon seeing a herd of cattle crossing the road. Now, let's look at our graph. Okay, so our graph, we've been told that it's a velocity time graph. So automatically what that means is that we should have velocity on the y-axis, and in this case, it's labeled as speed. Please don't get confused when you see the description of the question saying velocity and what is on the graph is speed. The only difference between speed and velocity is that velocity is actually speed, but in a specified direction. That is just the difference. Otherwise, velocity is speed. And when we look at the x-axis, we can see we have time there. We have time, and the total time of the whole entire journey was actually 10 seconds, because the x-axis is saying time in seconds and the y-axis is speed in meters per second. So let's now look at the question itself. So it's saying use the information on the graph to calculate. So what are we supposed to calculate? We are supposed to calculate A, the deceleration of the car between point A and point B. So we are supposed to calculate the deceleration of the car between points A and point B. The second question is the distance traveled by the car in the 10 seconds. So we're supposed to calculate the distance for B. For C, the average speed of the car. The average speed of the car. And C brings us to the end of this particular question. Remember, we're supposed to answer these questions in the spaces provided. Okay, so now let's go back to our graph and check point A and point B so that we can get the coordinates from the graph itself. So this is our graph, and if we look closely, point A, this is our point A, and point A on the y-axis, for point A, we actually have time equals 0, okay, and speed or velocity equal to 12. Now this is just the first coordinates that we actually have gotten. So at point A, t is equal to 0, v is equal to 12, and we now go and look at point B. Point B, this is our point B. Our point B, we now need to also take, so at B, we know that the time t is equal to time t is equal to, you can see there is a 4 there, right? And there is a 6 there. And the point actually lies directly here. And this is halfway. If we check, this is halfway. So this point is the point we're looking for. And this point represents 5. So t is equal to 5 seconds. T is equal to 5 seconds. And the velocity there is actually this point here. The velocity is 2. So v is equal to 2. Now, the velocity is 2. The velocity is 2, okay? And the time is 5. Now, let's get back and now do this the right way. I had just written for points A. For points A, I had just written. So this is where we had written for point A. So for point A, I had just written that V. Now, point A is the first coordinate. Point B is the second coordinate. So just for clarity's sake, for point A, we know that this is the first speed. So we're going to say U is equal to 12 and T is equal to 0. So these are the coordinates for our first system. So for point A, U is 12 and T is 0. So okay, so now we can now go to the questions themselves. So the deceleration. Now, deceleration is acceleration, but it is the negative of the acceleration. Remember, deceleration is acceleration, but it is negative acceleration. So if we start by just calculating the acceleration, it means we have to negate the acceleration at the end. So we know that acceleration is equal to v minus u over t, right? Therefore, if we substitute a is equal to v, what was the final velocity? The final velocity, we had v is equal to 2 and u is equal to what? Is equal to 12 from the graph. Then the other thing we had is that t at the beginning, so let's put it as t1. T1 at the beginning was equal to 0, and t for the second point, which is point B. So t for point B, which is t2, was equal to what? Was equal to 5 seconds. So we can now say that for us to find the time taken was just 5 seconds. That was just the time taken, 5 seconds. So let's substitute those. So we have 2 minus 12 divided by the time, which is 5. So we have 2 minus 12 divided by 5. So we will now have A is equal to 2 minus 5 is actually, the 2 minus 12 is actually negative 10. Okay? Then over 5. This gives us an acceleration of negative 2 meters per second squared. Negative 2 meters per second squared. Now remember, this is acceleration and not deceleration. The question asks us to find the deceleration. So what is the negative of this acceleration? So to find this, we just have to now find the negative. So the negative of negative 2 will be, so deceleration will be acceleration times -1. So it will be a times -1. So we have -2 times -1. This gives us a 2, a positive 2. A positive 2 meters per second squared. This is the deceleration. So the answer that we're going to put here on deceleration will be 2 meters per second squared. This is our deceleration. So we've just finished the first part of the question. And that is how we find the deceleration. Now, people will say, all this for just 2 marks. Yeah, you need to put in a little bit more effort to earn the 2 marks. A -2 meters per second will not score the 2 marks. That is for sure. All right. Now, the second part of the question is the distance moved by the car in 10 seconds. The distance moved by the car in 10 seconds. Now, when it comes to distance, we always take note of the following. When it comes to distance, we take note of the following. When we're dealing with a graph, it is important to know the following. It is important to know that the distance covered by the object on a velocity time graph is equal to the area underneath the graph. Now, what do we mean by the area underneath the graph? The area underneath the graph will be, so this, the line from A to B to C is our graph. Now, the area that is under here, this area that is under the graph, this area that is under this graph is the distance covered. Now, we need to take extra precaution when calculating area, because this is purely mathematical, and a lot of people will say physics is difficult, but this is not the physics. This is the mathematics, and we should know the mathematics and understand the mathematics so that we can actually interpret the physics behind it. So the area underneath the graph. So the best way to approach this is to actually divide this graph into sections that we can easily calculate the area. So what we are going to do is we are going to actually divide this. So I will start from 2 there, here. Okay, I'll cut it. Then I'll also cut it from B going downwards there. So B downwards, or I'll just cut it into 2 simple shapes. So these 2 shapes are 1. This is shape number 1. This is shape number 1. This is shape number 2. So I've got a triangle and a rectangle. A triangle and a rectangle. So for me to find the area, I need to know the base of the triangle. Because remember, area of a triangle is equal to half BH, half base times height. So area of a triangle is equal to half BH. So I need to know the base and the height. Then for a rectangle, area is equal to LB. So I just need to know the length of the base of the triangle and the height of the triangle. So this is how we're going to extract it. So the height of the triangle, how high is the triangle? The triangle spans from point A, okay, up to this point. So it is moving from 12 to 2. So how high is the length between 12 and 2? So the length is actually 10, because we're just going to say 12 minus 2. So 12 minus 2. So 12 minus 2 is our height, and this gives us 10. While the base is from 0, which is the starting point, to point B, which is 5. So it is 5 minus 0. So the base is 5, the height is 10 for the triangle. Then for the rectangle, so we have two things. B is equal to 5h. So we have B is equal to 5, H is equal to 10. So this is for the triangle. This is for the triangle. This is for the triangle. Okay. Then we now turn our attention to the rectangle. For the rectangle, the coordinates for the rectangle will be, it's from 0 to 2. So from 0 here to 2. This is our breadth, and the length is 10. The length is 10. It's spanning from here to here. So this is our length. So we have 2. So L is equal to 10, and B is equal to what? Is equal to 2. So we take note of these 2 points. Okay, so we take note of these 2 points. So B 10 and B 5, H 10 for the triangle, L 10, B 2 for the rectangle. So let's go back to where our question is. So what we're going to do is, the total distance is the total area. So we're going to say distance is equal to half BH. Okay. So so we're going to say distance is equal to half BH. This is it, the triangle. This scatters for the triangle, plus LB. This scatters for the rectangle. Okay. So now we just substitute. D is equal to half times B, which was 5, times height 10, plus L was 10, times B was 2. So this is, now we're now going to multiply. 5 times 10 is 50. Half of 50 is 25. So D is equal to 25 plus 10 times 2 is 20. So this gives us the total distance of 45 meters. So this was the total distance covered during the deceleration. So here what we're going to write is 45 45 what? 45 meters. Always take note. Check at the end, somewhere here. Sometimes the examiner will actually put the unit, sometimes they won't. So if the examiner has not put the units and you forget to put the units, then all your working may be, I say may be, in vain, because 45 alone is meaningless. It does not make any sense. It can mean anything. Yes, it can mean anything. Then finally we have average speed. Average speed. What was the average? What was the average speed of the car? What was the average speed? Now, when it comes to speed, we know that speed is equal to distance over time. Okay, speed is equal to distance over time. So because this car actually decelerated for some time, then maintained a certain velocity when it reached 2 meters per second and moved at a constant velocity of 2 meters per second for some time. Therefore, if we used those equations of motions, there is a section of the graph which is actually not accelerating. So the best approach here is we know that speed is equal to distance over time. So we know that speed is equal to distance over time. Okay, this is average speed. Why is it called average? Because the car may have changed its speed during the course of motion or the course of the journey, and we cannot specify the speed at each and every point, but looking at the whole distance covered and the time it took the car to move from point A to point C, we can actually deduce the average speed, which is just the speed it would take. So speed is equal to distance over time. What was the distance covered? The distance covered was 45 meters per second. The total time taken was 10 seconds. So speed is equal to 45 divided by 10. 45 divided by 10. So 45 divided by 10 will actually give us 4.5. So speed is equal to 4.5. Again, what are the units for the same speed? It's meters per second. So this is our speed, okay, and this is our average speed, and we can now place it there. So it's 4, sorry. So our average speed is 4.5 meters per second. This is our average speed. So this basically brings us to the end of this section or this video. I will be producing more videos on motion, and we will be going through more questions. Thank you very much for watching. Have a blessed day.